start differentiating, okay, it's going to be 3 cosine 3t in I direction plus negative 3 sine 3t in the j direction. And for the other one, I will have 3 over 2 times 2. So it's going to be 3t to the power of half in the k direction. As you can see, this is r. If I put t equal to 1, I will get the velocity or the slope of this function at t equal to 1. Okay, if I need to get the acceleration for r dash, it's going to be r double dash, so differentiating the main function 2 times, which means differentiating the first function 1 more time. Are you with me, Mr. Muhammad? So it's going to be a negative 9 sine at 3t in I direction, and for the other one, it's going to be minus 9 cosine 3t in the j direction, and the last one is going to be 3 over 2 times t to the power of negative half in the k direction. This is the r, this is the velocity, and then the acceleration. He needs you to find an equation of a tangent at t equal 1. In order to get such an equation, I know that I will be dealing with a straight line. And the straight line in parametric representation, it can be represented as the following. That's an equation of a straight line, as I told you earlier in the morning. Equation of a straight line is going to equal to the point which belongs to this straight line plus some constant which belongs to r times the direction ratio or the vector of this, or the slope, the vector or the slope of this straight line. In order to get the point, it can be got easily from the value of r. In order to get the vector that controlling this tangent straight line, it can be got from r dash. So all I have to do is to make substitutions in both r and r dash, and I will be able to get this tangent line. So let's start substituting with t equal to 1. If I start substituting with t equal to 1 in the first line, so the point will be, this is going to be the point. The point is going to be sine 3 in the direction of I, plus a cosine 3 in the direction of j, plus 2 in the direction of k. And if I want to get the slope or the vector in the direction of this line, all I have to do is to make this substitution but in r dash. So it's going to be a 3 cosine 3 in r, and the negative 3 sine 3 in y, and then I will have 3. This is a point, and that's the vector. Now I can write the equation of this straight line very simple. All I have to do is to get the tangent straight line equation. This is the point, which is going to be sine 3, cosine 3 and 2, plus lambda times the vector notation, which is, or the vector value, I'm sorry, 3 cosine 3 minus 3 sine 3 and 3. Now I will have the parametric representation of this equation. Once more. This is the shape of the first function, which represents a spiral that's moving in the positive direction. Why moving in the positive direction? Only because you have a root here. This is 2 of t cubed under a square root, positive square root. So just only the values of these greater than 1, that will exist. Now, I will get, this is r, I will differentiate to get r dash, and then differentiate once more to get r double dash, which is the acceleration. Exactly like what we did. If I want to get the equation at t equal to 1, it's going to be the point plus lambda times the vector. The vector will be, you will be able to get the vector from r dash and the point from the main function. So all I have to do is to make a substitution with t equal to 1 in R, then t equal to 1 in R dash, and that's exactly what I did. This is the point, and that's the direction vector. It's exactly what we talked before. So the equation, the parametric equation of this straight line, it will be the point plus lambda times the vector, and then try to expand it. Once we expand this guy, I will have sine 3 plus 3 lambda cosine 3 in the direction of I, cosine 3 minus 3 lambda sine 3 in the direction of j, and so on. And as you can see, a vector function will have a tangent as also a vector function. Okay. Similar manner, if I want to do this for the second problem, but the second problem will be a little bit complicated in the derivative. Because if you remark, these are two functions multiplied in each other. So with each time you make a derivative, this component will go larger. So that's the case of this guy, okay, at root 3 and t. Okay, here we go. These are the derivatives, one by one. This is gonna be the point, exactly the same, but I will make a substitution at 0, so it's gonna be the origin. And then I will get the direction vector, which is gonna be 1 on root 3. This is the equation of the parametric equation of this tangent line, which is gonna be like 0, lambda, root 3, and lambda. These problems are very important. I will try to upload this lecture as fast as possible for you. I believe it will take a couple of hours before you can see it on YouTube, so you can follow it. Please try to resolve these problems using your hand, exactly like what I'm saying, what I'm doing. I usually read everything very well, then I use my pen in writing all of these information. Try to understand if it was an MCQ exam and he's asking you about a tangent for this function at certain point, and you will have to do all of these steps in order to get a suitable representation of this function. So the choice is not going to be that easy unless you solve it by your hand. Thank you very much. I'm sorry that I took a lot of your time, and I will see you next time, inshallah. Thank you very much. Thank you.